Electricity is all around us. It is the most common source to power technology, like our cell phones, computers, lights, basically all the electronics devices that we use every day. But what exactly is electricity? This is a very complicated question, and as we dig deeper and ask more questions, it gets even more interesting. Hello everyone, welcome to my channel, Learn, Share, and Grow. My name is Aryan, and in today's video, we will learn about electricity, some basic terms, and some interesting facts. Let's get started. So what really is electricity? Electricity is briefly defined as the flow of electric charge, but there's so much behind that simple statement. Where do the charges come from? How do we move them? Where do they move to? How does an electric charge cause mechanical motion or make things light up? So many questions. To begin to explain what electricity is, we need to zoom way in to the atomic level that make up everything we interact with in life. First, let's try to understand what an atom is. Atoms are one of the basic building blocks of life and matter. The word atom comes from the Greek word for indivisible, because it was once thought that atoms were the smallest things in the universe and could not be divided. However, according to the Bohr model presented by Bohr and Rutherford in 1913, atoms consist of three particles: protons, neutrons, and electrons. Protons and neutrons are heavier than electrons and reside in the nucleus, which is at the center of the atom. Electrons are extremely lightweight and exist in a cloud orbiting around the nucleus in various shells. The outermost shell is called the valence shell, and the electrons in the valence shell are called valence electrons. So let's understand some facts about these particles. Every atom other than hydrogen must have at least one neutron. Neutrons are slightly larger than protons. Adding a neutron makes an isotope, or a heavier version of that atom. Neutrons are responsible for keeping the protons in the nucleus. Neutrons are uncharged particles, so they're not critical to our understanding of electricity. And we will focus on protons and neutrons in the rest of the video. Every atom must have at least one proton in it. Each element has a unique number of protons in their atoms, and adding a proton to an atom makes a new element. For example, carbon atoms have 6 protons, hydrogen has 1 proton, and the count of protons is called an atom's atomic number. Electrons are extremely lightweight. They are about 1800 times smaller than protons, orbiting around the nucleus, and they're critical for electricity. Okay, so let's understand how. Atoms have an equal number of protons and electrons. Protons are positively charged particles, and electrons are negatively charged particles. Both electrons and protons carry the same amount of charge, just a different type. Therefore, atoms are charged neutral. As we just learned, electrons exist in a cloud orbiting around the nucleus in various shells. Each shell can hold a fixed number of electrons, which you can find with the formula 2n squared. Once the inner shell is filled, the electrons start orbiting in the outer shells. And according to the Columbus law, charges of the same type repel each other, while charges of opposite types are attracted to each other. The amount of force acting on two charges depends on how far they are from each other. This means the valence electrons require the least amount of force to be freed from an atom. Using enough force on the valence electron, either pushing it with another negative charge or attracting it with a positive charge, we can eject the electron from orbit, creating a free electron. This free electron eventually latches on to another atom, ejecting another valence electron. This chain effect continues with more electrons drifting through free space, and such constant flow of electrons is called electric current. So now, to understand how to use electric current, let's quickly discuss 3 more actors: the conductor, insulator, and circuit. Conductors are the elements with atoms having very mobile electrons. These are generally used for making electric wires. Some examples are copper, silver, gold, and there are many more. Elements with low conductivity are called insulators. Few examples are glass, rubber, and plastic. Oh, and by the way, air is another example of an insulator. Finally, electricity requires a closed, never-ending loop of conductive material. Such a loop is called a circuit. This can be as simple as a conductive wire connected end to end, but useful circuits usually contain a mix of wire and other components which control the flow of electricity. The only rule when it comes to making circuits is that you can't have any insulating gaps in it. Let's do a quick recap. What do we need for electricity? First of all, we need the constant flow of electric charge. Secondly, we need a little push to free the electrons from their atoms and get them to flow in a generally uniform direction. Thirdly, we need a closed circuit made out of conductive material. This provides a path for the electrons to continuously flow. And lastly, we need a source of voltage. This gives that little push to free the electrons. So, now that we know how electricity is produced, let's briefly understand some key concepts that are important to design electric circuits. Number 1, the circuit itself. When we create a closed loop by connecting two ends of the power source using a conductive material, it's called a circuit. Number 2, voltage. Voltage is the pressure exerted by a power source, and it's measured in volts. Number 3, electricity. Once again, it's the constant flow of charge, which is usually carried by free-flowing electrons. Number 4, current. Once an electric circuit is created, electrons start flowing, and the speed of the flow is called the current. Current is measured in amps, or amperes. The circuit generally also includes a component called the resistor. This helps control the current flow. The resistance is measured in ohms. Finally, we connect the devices that we use in our everyday life, such as bulbs, to the circuit. Okay, some fun time before we get into electric circuit design. Look at the circuit here. What happens if we don't connect a bulb in this circuit? Well, think about it. Without any resistance, the flow of the charge will increase, generating a high flow of energy. The energy moves very quickly through the system and is transformed into heat in the wire, which may quickly turn into melting wire that can cause fire. This is called a short circuit and can be very dangerous. Never try this. Okay, now a quick quiz. Why do you feel an electric shock when turning the doorknob, particularly when walking off the carpet? And what is this called? How is it different from the electric current? I will explain this interesting theory later in this video. Okay, so now we know that a circuit is required for electricity to work. Let's dive into some designing ideas and types of circuits. So there are two types of circuits, series circuits and parallel circuits. The basic element of designing any electrical circuit is to calculate and control the voltage and current flow in a circuit. According to Ohm's law, V, or voltage, is equal to I times R, or current, times resistance. In other words, the higher the resistance, the lower the current. Let's look at how we calculate voltage, current, and resistance in a series and parallel circuit. Let's start with series circuit. A series circuit has only one path for current to flow. Let's understand how we can calculate the resistance, current, and voltage in a series circuit. The total resistance will be the sum of all resistance in the circuit. The series circuit has only one path for current to flow. Therefore, the current remains the same for the entire circuit. Finally, the voltage will split for each resistor based on Ohm's law. Let's look at one simple example. This series circuit has a voltage source of 12 volts and a resistor of 1 ohm. The total resistance will be the sum of all resistance, which is 1 ohm. The current will be voltage divided by resistance, which is 12 volts divided by 1 ohm, and that's 12 amperes. And the voltage drop for the resistor will be 12 amperes times 1 ohm. That's 12 volts. Okay, another example with two resistors in a circuit. The total resistance will be the sum of all the resistances, which is 2 ohms plus 1 ohms, 3 ohms. The current will be voltage divided by resistance, which is 12 volts divided by 3 ohms, and that's 4 amperes. The voltage drop for resistance based on Ohm's law will be 4 volts for the 1 ohm resistor and 8 volts for the 2 ohm resistor. So the total circuit voltage will be 4 volts plus 8 volts, which is 12 volts. Let's discuss how a parallel circuit works and how it's different from a series circuit. Parallel circuits have multiple paths or loops for the current to flow. All the loops are connected to the same end of the power source. Therefore, the voltage remains the same for each loop. The current, on the other hand, will split for each loop, and it's calculated using Ohm's law. The total resistance will be calculated using the formula. The inverse of the total resistance is equal to the sum of the inverse of resistance for each loop. You will soon learn that the total resistance will be less than the least resistance in one loop. So, in this example, each path will have the same voltage. That's 12 volts in this example. For path 1, the current will be 12 volts divided by 3 ohms. That's 4 amperes. For path 2, the current will be 12 volts divided by 6 ohms. That's 2 amperes. For path 3, the current will be 12 volts divided by 3 ohms, which is 4 amperes. And the total resistance of the circuit will be R1 times R2 times R3 divided by 2 times R1 plus R2 plus R3. And that will calculate to 2.25 ohms. This is less than the lowest resistance in any loop. Congratulations! You have just learned about how electricity works, the Bohr model of an atom, and the key concepts of electricity, the type of electric circuits, and Ohm's law to help you design circuits for your projects. Here is a quiz to evaluate our understanding. Review the circuit diagram and calculate the readings of each yellow multimeter for current. And wherever you see the black multimeter, calculate the voltage as well as the current. Write your answers in the comments down below. Also, feel free to ask any questions. Before we wrap it up, let me quickly explain why we get an electric shock when we touch a metal doorknob after walking off a carpet. Well, our body is a conductor, and the carpet is an insulator. As we've learned before, a conductor can easily lose electrons, and an insulator can easily gain them. So our body loses some of its electrons to the carpet. Then when we touch the doorknob, which again is a conductor, the metal doorknob loses its electrons to our body. This is for our body to go back to its equilibrium of having an equal number of protons and electrons. So the sudden flow of electrons is why we get a little static shock. No wonder this boy's hair is dancing around. Well, that's all for today. Stay tuned for my next video, all about Arduino and interesting projects. Don't forget to like, share, and subscribe to my channel.